Hi guys. So in this video, we want to talk about the 4.7 beta version of pyRevit. As you have noticed, we have added another major version, well, minor version basically to the version number. This is because of a very exciting feature that is being introduced in this beta version, which is the CPython engine for pyRevit/Revit. So up to this point, we have always used the different Python engines to be able to run Python inside the Revit environment. With the introduction of a project that's called PythonNet, this project, this is basically a module that you can install on CPython and access the .NET runtime information and libraries and stuff like that. So this brings the power of .NET Framework to the CPython environment. I've been thinking about incorporating this into Revit for a while, and what is it? Finally, I got a chance to be able to sort of like get it tested and add it there. It's still a little buggy, so you might see errors popping out here and there. But the goal is to get this out to you guys so you can start testing with your own libraries and stuff like that and see basically report the errors and see how far we can take this. The pyRevit itself still runs on IronPython, so the majority of the environment is still the same, but you can choose your custom scripts to be executed under the CPython environment, and I'll explain how this works. So this is the about window. You'll see that it's a 4.7.0-beta version, and it's a different branch from the original. This is not replacing the 4.6 that's out there. This is just the beta version to get it out to you guys so you can start testing. All the tools are still the same. Under the settings, on the core settings and engine, there's a new configuration for the active CPython engine. As I mentioned, pyRevit still runs on the IronPython engine. This is the runtime engine for pyRevit. All its tools, all the libraries, Python library, RPW, all these modules are written with the IronPython in mind. So that's why sort of like that needs a lot of work for the CPython to be a runtime engine for pyRevit. It still needs to be tested. Hopefully that'll be a goal for the full version of 4.7. There's a lot of tests that need to be done, but basically you can choose from the two different the CPython engines that are being shipped with pyRevit. pyRevit uses if you go on their python.org website, if you want to download, like for example 3.72, there's a version of this Python that's called the embedded, which is embeddable basically. That's the CPython version of CPython that's designed to be embedded into other applications. So pyRevit, under its, if you go under bin directory, engines, you'll see these two new engines that have been added, 368 and 372. And inside this, there's DLLs and modules and stuff like that that are related to that version. It includes this runtime environment includes includes the Python standard library and some other miscellaneous things, but everything else, all the other libraries are not included in the pyRevit. Like for example, if you need NumPy or SciPy or other scientific packages that you need to use, you need to install those on your machine. So this is the most important thing about using this CPython with Revit, that you don't necessarily need to have CPython installed on your machine. But if you want to be able to use other extra modules and libraries and stuff like that that are associated with CPython, you either have to download those libraries and put them in a folder and sort of like add that search path to your system path, or you can install the CPython on your machine. Just be aware that you need to install the 64-bit version of the CPython. So if I say Python here, it's actually clear. Apologies, wrong button. Okay, switching back between Mac and Windows, gets confused on the. So Python. So pay attention. Then you need to have the 64-bit version of the this is here, AMD 64 version of the Python. You can use the 372 or 368. Now, this means that when you install Python this way, you'll have the PIP that is the Python package manager that belongs to that Python version that you're using. So if you install, like for example, I've already done this, but if you install NumPy, for example, this is already satisfied. I've installed it, but basically installs the NumPy for the 3.7.2 that I've installed on my machine right now. The directory that NumPy will go to is this directory, which is the site packages, the standard site packages directory for Python. What you have to do is that you have to go to your environment manager in Windows, go to environment variables, and add a Python path environment variable. This is a standard to Python. It's nothing about our conventions and stuff like that. You'll add the Python path and you'll put the path of the site packages directory for your Python. This means that when this Python path environment variable is available, this is one of the paths that Python uses to sort of like look up the paths. And that applies to the embedded engine that pyRevit is using to run your commands. So if you add this to your environment and everything else, then the command that you run through pyRevit in CPython will be able to pull the modules that you've installed using pip. So like for example, I'm going to do a pip list here just to see. So I don't have, let's say, I don't have pandas installed. And if I need to install pandas and use it with Revit, the only thing that I have to do is to say pip install pandas. And it would install it for me, and the path is added to the environment variable, so my scripts inside the Revit environment will be able to see it. Now, under settings, if you open the core settings, there's a detailed explanation of how this system works, and I've explained everything that we talked about, the 64-bit version, the Python path environment variable, and the last thing that we want to talk about is that all these scripts are basically the same. This CPython command that you have, it's still a Python command. It's still, I'm sorry, a Python script. So if I want to open this, test CPython command script. So it looks just like any other Python. It's just that you're writing in Python 3 format. So like, for example, for Python 3.7, I'm using F strings, which are the new way of formatting strings in Python. So you could use these. And then basically that's how it works. Now, this script will fail under IronPython because, for example, IronPython doesn't support these F strings. So you kind of have to be aware of the differences between the 2.7.7 or 2.7.9 of IronPython version of Python and then the Python 3 language standard. So these two are different from each other. Now, the way you tell pyRevit to run that command using the CPython engine, you can't tell pyRevit which version of these CPython engines the pyRevit should be using, because that's when it's loaded one time in the Revit environment, it's kind of like fixed. So the way you tell pyRevit which version to use is this, and it's fixed for your session. So you can't have a script that runs on 3.368 and a version that runs in 372 in the same session. So this is kind of fixed. Pick the one that you are comfortable with. Generally, the selection should be based on the libraries that you want to use. If you don't have crazy libraries and if they're available for Python 3.7, use 3.7. It's the newest version of CPython. And if not, if there are libraries that are not available for 3.7 yet, you can roll back to this 368 and install that on your machine with the libraries that you need. So the way you tell pyRevit how to run that script in the CPython is described also in here. It's a standard convention for, especially in Windows, to run to basically tell the runtime, the Python selector basically to which version of installed Python you want to use to run your script. So the only thing you have to do is to put hashbang space Python 3 as the first line in your script. So when you add this line to the script, the IronPython, the pyRevit itself, when it's loading, it does not look at your string, what is it, the script anymore, because of the differences that are basically available for different pyRevit standards. Like if the IronPython running 2.77 tries to read this and determine the syntax tree, it's going to fail because it doesn't understand something like this. So that's something that would be available when we actually move the complete Python, the complete pyRevit runtime into CPython. But as of this moment, as when you elect to run your script in Python 3, almost everything else that you have is on your own. There are no context. You can't use any of these features, the context, the title, the help, and all that kind of stuff, because pyRevit is not going to look at those anymore. That's temporary. You cannot do like import pyRevit because the pyRevit module has been written for IronPython. You can't import RPW because that's the same thing, and all the other IronPython modules that have been written. So you kind of are on your own, but at the same time, for now, it gives you the ability to import modules, CPython modules like NumPy and SciPy and pandas and other stuff. There is a module that's called CLR in this python.net basically implementation. It looks and feels very similar to the one that's in IronPython, but there are differences between the two. So just be aware that this import CLR that you're doing, this CLR module is vastly different from the one that's in IronPython, because the whole runtime environment for this script is CPython, and it's using the python.net implementation. And that's radically different from the way IronPython looks at Python execution. So you use this, and then you can import the CLR. And as you can see, I've imported the Autodesk Revit DB. The rest of it is pretty much the same. Using the Revit API is still the same. As you can see, I've like a standard filter element collector. The Revit, Dunder Revit, you should assign it from syshost. So you should import the, and I'll share this example of script on the blog post. So import sys, and then you can access the Dunder Revit using the syshost. A lot of this is still under considerations, and I'm going to change this in the future, hopefully, for the sort of like a more streamlined workflow between the two of them, between the IronPython and CPython, so they're like, closer matches between the two. This follows the pyRevit convention that there's a host app, sort of like, variable that points to the host, and then you can give it whatever name that you want. Some people like the Dunder Revit, or you can call it whatever else that you want to do. But basically, that's the UI application that you need to access and to get your document, active document, and all the other stuff. And as you can see, I'm creating a filter element collector for walls and printing a list of walls. And also, I can use a f-string, print the wall object itself, and then pull a property value from that wall element and print that one as well. So just to reiterate, you don't have access to any of the sort of like pyRevit features, which is the import Python or import RPW or all the other IronPython modules. But because it's Python 3 and it's such a vastly different environment from what pyRevit is at the moment, or IronPython really is at the moment. But at the same time, you still have access to Revit API, so you can write your own functions and whatnot, and then sort of like, go through it and try to do whatever that you need to do. But the upside is that you have access to all these CPython modules. For example, I don't have access to the output, the script output that we have that controls the output window in pyRevit IronPython. So I've sort of like recreated a print HTML function here that uses the sort of like the convention of the pyRevit output window to print HTML string. So you can grab this stuff from here and recreate a couple of functions for yourself here to make life easier for you. This is temporary, hopefully. So eventually the goal is to move pyRevit completely and make it adaptable to CPython, so you can elect between IronPython or the Python.net, which is going to be basically the CPython as your execution engine, as your runtime engine. So what you have to do after you install the pyRevit 4.7 beta, you go to settings, and then you go to core settings and elect which one of these versions that you want to use, depending on the modules that you have installed on your system. And then you go to write your environment variables, set the environment variable, the Python path correctly to the side packages. And after that, you're pretty much good to go. Create your script, throw it in the, panels and stuff that you have. For this example, I'm going to click on my script. And as you can see, the execution speed is insanely faster than IronPython because this is really running on CPython in the backend. Just to let you know, IronPython compiles a Python. It's an implementation of Python in under .NET. So it on CLR basically, which is the common language runtime for all the .NET application on the programming languages. So what IronPython does is that it reads your Python script, it translates it into CLR bytecode, and then executes it on the machine. The upside is that it can talk to any other C# or VB# or whatever, all the other CLR modules and stuff like that very easily, because basically Python has been taken and translated into the CLR world. The way this CPython and the Python net works is that it provides wrappers around the data types of CPython to be able to connect those to the basically the CLR environment, but all the execution still happens on the CPython module. So that's why if you go under the pyRevit engines, under 3.72, for example, see that Python 37.dll? That's a DLL, that's a library that provides all the functionality, all the execution functionality for the CPython itself. That's basically CPython. So PythonNet, Python.runtime, which is the DLL for PythonNet, connects to this and asks the DLL to run your script. The benefit is that it's insanely faster because it's running on the CPython engine, really. In this example, I'm grabbing the sys information, printing that on the first line. As you can, I'll share the script so you'll be able to see it. I'm printing all the sys paths for you to see what kind of system paths are added to the sort of like the sys path. And as you can see, the first one is that Python path that we put in our environment variable. So that will pull it. So all the modules will pull from here. And then as you can see, I've already imported NumPy and created an array and printed that. It tells me that I don't have pandas on my machine, so it failed the loading of pandas. And then UI application, the UI application is printed correctly. That means that it has access to Revit. And then the list of DB walls. Now I don't have any walls in this model. Let's go create a couple. And then go run the script. See how fast this is? And then these are the walls that we have. Now I'm going to go and install pandas on my machine as well. As you can see, I'm using the pip for 3.7 Python 64-bit that I have installed on my machine, so it correctly pulls the right package and puts it in the site packages. So we'll wait for this to install. And after that, we should be good to go. Okay, so pandas is on my machine. And then I can just rerun the script. It imports the pandas module, and I can now print the pandas data frame. So the way, just to show you this again, I'm pulling the pandas data frame, and we are sort of like changing that data frame, exporting that data frame to an HTML, and then get rid of all the line endings, and then using that print HTML function that basically translates all these greater than and less than characters into the custom format that is the pyRevit output window, and it basically feeds it to the pyRevit output window so it could be printed correctly. So that's what you see here. You can easily use that, and then you can see all the walls and stuff like that printed there. So that's pretty much it as far as the testing of these CPython engines go. You can get it tested and let me know what you think. I'm pretty excited for it just because of, we can finally easily access the NumPy and SciPy and stuff like that inside that Revit environment. Now, as I mentioned, there are some bugs around it. Like for example, on my machine, on my virtual machine that I have on my laptop, this happens. When Revit is exiting, after execution of after I've used the CPython command, I get these two DLL not found errors, which they exist. I have no idea what these errors are coming from. But this doesn't happen on my work machine, so I don't really haven't figured out the root of the problem. So you might see stuff like this. Don't use this 4.7 beta version of pyRevit in your production environment. This is only for testing purposes. I mean, you might be able to get your work done without any issues and whatnot, but it's just, don't ruin your projects by not testing this fully. I've shared this script on the blog post. Now we're going to talk about the second feature that's being introduced in this version, and that's a new type of extensions for pyRevit that's called run extensions. If I go under the pyRevit extensions directory, you'll see a new pyRevit run extension listed there. The pyRevit run extension is basically a list of Python commands. They all have to end with _command.py. And what you can do is basically you have to go back and watch the video that we talked about the pyRevit run command, that you can run a Python command over a Revit model. So you can say pyRevit run that command over my model and use whatever version of Revit it is. It's actually smart enough to take a look at the version of the model and run the correct version of Revit, but you can just enforce it into a different version of Revit as well. So that's a sort of like an automation system that the pyRevit CLI has. Now, instead of the pyRevit extensions, these run extensions provide functionality, commands for this run that you can create and you can share with everybody else. The way to run this, you can just say pyRevit run, and I can say make 3D view and then run it over a model that I have. So imagine, I don't know, like this is the path of the model that I have. So you don't have to give it the full path of the Python command. pyRevit run will look into the version of Revit that it needs to run. It looks into all the extensions that you have installed on your machine for pyRevit, finds the run extension and looks up this command in the run extension. So in this case, the command name is first and then _command.py. So it finds all the Python scripts that end with _command.py, grabs the name, figures out that that's the command that you want to run here, and then executes it. Now the pyRevit extension manager still recognizes these extensions and can install it for you, install and remove and stuff like that. Because this way it's just easier. So it doesn't use them because these are for pyRevit. Like you can still see the pyRevit run here and it tells you that that's a CLR run command extension. The pyRevit environment itself doesn't use this, so there's no disable enable button here. But you can, if it's not installed, if your application, your extension is not installed. Now, currently this is a built-in extension, so there's not even an install button on it. It's built in and it's shipped. But if you have your own extensions, extra extensions, you can see that there. And if you take a look at the extension JSON inside that extension, the type says run, which defines the type of the run extension. So you can create your own run extensions and share in between your different environments and different people and stuff like that. And they can go and use the install that extension and then use the pyRevit run command, use those commands defining that run extension with the pyRevit run command to run those over the Revit models and whatnot. So this is a little bit more of an advanced feature, but it sort of gives you a much easier way of sharing all these scripts that you create for sort of like automating grabbing data over models and stuff like that. There have been a couple of more improvements to this. The pyRevit older versions are still there. So the last version of the pyRevit is 4.6.15. I'm not going to delete this, obviously, for now. So this is still the current stable release of pyRevit. So you can still keep using that and stuff like that. I will do hotfixes and corrections to this version going forward, but I want to get 4.7 beta in your hands as quick as possible so you can get started on the testing and whatnot. Now, the last thing that I wanted to mention is that the 4.7 uses a newer version of the CLI, which is the 0.12. The latest version that's pushed out there is 0.9. This version of the CLI is the one that supports these run extensions and stuff like that. I'll publish that after this soon, so everybody else can use the same version. But if you really need to use this pyRevit command extensions, the pyRevit run extensions with your run command, you need to use the newer version of the pyRevit CLI, which is the 12. So if you have installed the 4.7 beta using the installer and everything else, just make sure that your system path is basically directed to this bin directory here, so you can use the 0.12 version of this pyRevit command. The older version obviously doesn't support when you say run and put a command name in here. It doesn't. It expects a Python script still to be there. So this newer version is the one that supports the run commands and the run extensions and stuff like that. So that's there, and that's pretty much everything that I wanted to talk about. I'm really excited for this. What was that one? Really excited for the CPython. Get it tested. Let me know if you have any ideas and whatnot. Take a look at the blog post and the examples. Grab those, play with them, and report any issues that you'll see. One last quick thing: the output window of pyRevit also has a newer update on this version tag. So you can see the version tag is longer now. It includes the engine that's being executing the script that's producing the output, and also the running version of Revit. So now if you send me screenshots of this window in your error reports and whatnot, I'll be able to see which Revit version and which engine version and exactly which pyRevit version you're using that has generated the error and stuff like that. So that's a little bit easier for debugging purposes and whatnot. That's it. Thank you. Keep me posted on your tests, and let me know what exciting stuff you can come up with. Thank you.